Hello, scholars, and welcome to Unit 8. In this unit, we're going to be talking about different phases of matter and our ideal gas laws and how matter changes from one phase to another. So let's start at the beginning. What are the different phases of matter? You may have learned that there are three phases of matter early on in elementary school. There's actually four, okay? One's a little bit more technical. We don't really see it that much in our everyday lives, but we're going to learn about it here so that you understand the bigger picture. All right? So we have four different physical states. All right? A little bit different on the notes than normal. There's a lot of text down here, and I think they said it well, so I didn't need to say it again. So I want you to copy this whole slide down onto your notes, onto your template. Okay? Our four phases are solid, liquid, gas, and plasma. And they go in terms of increasing energy. Solid is our lowest state of energy. Liquid has more energy than a solid. A gas has more energy than a liquid. And plasma is the highest energy state. All right? So what do we know? In a solid, all right, the molecules make up a regular shape. All right, there's a repeating pattern. The atoms or the molecules, depending on what substance you have, all right, form a regular pattern. They're stacked tightly, they're stacked together, and they are in the same pattern because they're frozen that way. Right? You can think of it as frozen, not like water, ice, but that they can't move. All right? They're held firmly in place, and they can only vibrate a little bit, because when they vibrate, boom, they bump into the next guy, the next atom, the next molecule. And they vibrate the other way back, boom, and they hit somebody else. So they're packed into this solid form. Okay? Just like water, ice, when we give it more energy, going from low energy to higher energy, we heat it up. Those molecules are going to get freedom to move. Okay? They can flow. They can slide here, they can slide there, they can slide throughout this container. Okay? So they have enough energy to break free from that lattice or that rigid pattern structure of a solid. But they don't have enough energy to go flying up into the gas phase. So they have energy enough to move around and to be free within the confines of that container. Now, liquids are more dense than a gas, so they settle into the bottom of a container. Here's my container. Notice they fill a certain volume. All right? I can measure this volume. The molecules may move, but I have a certain volume here that I can measure. Okay? Now there's forces between these atoms or molecules that keep them tied together and pulling on each other so that they can't escape into this gas phase. All right? I add energy to my liquid, usually in the form of heat. I heat it up, and the molecules get vibrating so much they can escape and poof, break free. When they do that, we enter the gas phase. Each individual atom or each individual molecule is no longer bound to the other ones. Why? They've got a lot of energy. They have a lot of velocity. They're moving so fast that their momentum overcomes the force of attraction between those molecules. So any push or pull they have on each other is insignificant. Down here in a liquid, it's lower energy. Forces are keeping them in the bottom of the container. And a gas, the force interaction between the molecules is so small, you can pretend it's barely even there. So gas is going to expand to fill the container, not just the bottom of the container like a liquid, but the whole container. So molecules in the gas are going to move apart and bounce off each other in all sorts of directions. They fill the entire volume. Okay, last but not least, plasma. Notice, I heated a solid to become a liquid. I heated a liquid to become a gas. If I heat a gas hot enough, I can get those atoms and molecules so excited, so fast and moving, such high velocities that the electrons, which are part of the atoms, get torn off And as those electrons get torn off, they become ionized. They become charged molecules because they don't have the right balance of negative charges and positive charges. When I strip those electrons, I've got my nucleus moving separate from my electrons, which gives me charged particles. This happens at really high temperatures at the center of a star. Also, on a much, much smaller state, this is how plasma TVs work. Okay? So 4 states of matter: solid, liquid, gas, plasma, going from lowest energy to highest energy. Make sure you copy this down. You write your questions. Write down something you heard that wasn't written on the side, and we'll see it in class.